Thank you. Good morning. This talk is titled, it doesn't run on my machine, which when you venture into serverless, you will figure out that a lot of the services that AWS offers actually don't run on your machine. I'm Markus Tacker. I live in Trondheim now for 2.5 years. When I go on conferences, I always bring a nice picture from Norway so that people actually know that it's not cold and dark all the time. We actually have white sandy beaches there. And I work at a company called Nordic Semiconductor. Who has heard of them? Okay, a few. Well, we're known for BLE and short-range wireless, and now we have this small silver thingy there. It's the nRF91, which is a long-range chip, and it's long-range because it can connect to the cloud, and this is where I work at Nordic. I'm working there now for 2.5 years, roughly. And the first 2 years I worked on nrfcloud.com, which is our prototyping platform for IoT products. And since roughly half a year, I've started another project, which is an open source end-to-end example for a real IoT product, which gives you everything from the mobile web app to setup with CDK for your cat tracker, everything on AWS, so you can check that out. And the solution I'm talking today about actually is used in these two projects and is dating back further than maybe, I guess, 4 years. When I started to look into AWS, I started already having this problem. So that's kind of battle tested in a sense, and it works for the teams I work with, in the scenarios I work with. And that's why I thought, let's share it, and maybe more people find that helpful. Important to know that everything that I say is my personal opinion, and my employer doesn't necessarily share them. And a quick advertisement before we start in the content. I am a conference buddy. That means I go a lot to conferences, and with Conf Buddy we try to make conferences more inclusive and increase diversity there. This is a very simple system where people who are experienced at conferences are there and available for first-timers and newcomers. And we have an online forum where you can enter your upcoming conference and just be available for first-timers to connect. So I'd like you to check it out and think about how can we make our communities more inclusive and more welcoming to people that maybe don't look like most of us here in the room, like a white dude from Europe. So let's look at what we're going to talk about. I'd say roughly this is, you should have some knowledge about testing. I assume that you are familiar with unit testing a little bit. And obviously the problems in designing and developing a cloud-native serverless solution. So as I mentioned earlier, the problem is then that this solution that you're developing, you can no longer run on your own computer, which you're maybe used to when you write unit tests or even small end-to-end tests and integration tests. Because in the past you could download the Postgres and run the process and have your Apache and your Node.js, everything is local, but with serverless that no longer works. And I will explain how I tackle this problem and give some of the best practices that I found out were very valuable when running these tests. And in the end, I will also show you how I express or write the tests. And I use Gherkin for that, which is a very, it's a plain text in the end that drives our tests. So, to start, this is maybe you're familiar with the classic testing pyramid. A lot of the elements in that testing pyramid are structured in a way that on the top are the the tests where you have the fewest of because they are the most expensive ones. In the middle, you have the integration tests for your services, and then the base is a lot of unit tests. And the assumption in the past was always everything of that runs on your machine. So you can spin up everything when you're on a plane or when you have no internet connectivity and have all the services available for running your tests against. But with serverless, suddenly this no longer applies. So there is a part that may run on your machine. If you're like, I write lambdas in TypeScript, I can execute TypeScript code in Node.js, but we build an IoT solution, and I don't get AWS IoT as a binary to download. I can't, so it doesn't run on my machine. So that's basically the issue I have. The example project that we're going to talk about, and which will serve as the solution under test, or the system under test, is a part of what we've built on NRF Cloud, is a way to convert an incoming MQTT message into a webhook. The user story behind that is that as a notify me using a webhook if a device measures a temperature above 5 degrees. The background is that you could imagine that you have a customer who operates a cooling facility, a warehouse, and he has a bunch of temperature sensors there, and they want to receive a notification if one of the sensors measures a temperature that is above a threshold, so that it ends up in their system. The setup, the roughly what will happen technically is that on the left-hand side we have the device. It's a BLE device that's measuring temperature, and it's using a gateway to send these temperature readings to the IoT broker on AWS using MQTT, and into our system, nrfcloud.com, and there we have the ability for the user to configure a condition. They use a REST API. That's a smiley face coming from the top. Yeah, okay, I don't have a. Do I have a pointer? No, I don't think so. That's a smiley face on top. That's the user. They configure, okay, I want the notification if the temperature is above 0 in that example. So everything above 0 will trigger a notification. And then our system detects, looks at all the messages, and if one of the messages contains a temperature that's higher than 0, it will create an HTTP post request to the customer server. The setup, in order to achieve all of that, these are the AWS services involved to get it done, and it's quite. I'd say it's a normal serverless setup. We have on the left-hand side, if we start on the top, again the devices that talk to IoT. IoT is connected to lambdas through rules. So we have a lot of rules that listen to incoming messages and process them, store these messages in Elasticsearch or in DynamoDB tables. They also put messages in SNS for other services, again, to react to them. Then on the left-hand side, the smartphone represents the user. They have different APIs to use. We have a RESTful API, but we also have a GraphQL API. So we use API gateway and AppSync for the user-facing or the machine-facing APIs. And then we have outgoing messaging on the top, where the lambdas actually send the webhook requests to the customer systems. And a little bit on the side, under the hood, is like the more standard services, Route 53 for setting up our domains, S3 for hosting the static website, EAM for managing the permissions, CloudFront for actually serving the website through SSL, and the certificate manager for SSL certificates. So it's kind of typical, I'd say, web application scenario. And of all these things that need to work for my user story to work and for my customer to be happy, I can run these on my machine. So I get lambdas, we write lambdas in TypeScript, so I can get the code and run it using Jest in Node.js. Elasticsearch is an open source product where I can download a binary and run my local Elasticsearch server. And AWS gives me a DynamoDB binary, which gives me a database that behaves like DynamoDB. These are available on my system. The rest is not. So all of the other parts, there is no local version. And that's actually the point why we go to a cloud provider. They should be solving the problems for us, and we go there for scalability and for security and for fault tolerance. And obviously that makes it clear that these services span multiple machines and multiple instances. So replicating them on my machine kind of is not what they are made for. So, yeah, as a tester, so what can I do? I could, replace them. Why not find local alternatives for that? So I could go around and replace IoT with Mosquito. Mosquito is an open source MQTT broker. The AWS IoT broker follows the MQTT 3.1 specification, mostly. So I can just replace it with an MQTT server. AppSync, I can replace it with Apollo server. It's an open source GraphQL server and client. API gateway is my typical Node.js Express server. For SNS, I can use ZeroMQ as a message queue, and logging is done through my local syslog, so I don't need CloudWatch for that. I can just log to a file. And then the rest of these other services, I can also find replacements for them. Route 53 is just DNS. S3, Nginx for serving the website, as well as for the SSL certificate. And yeah, okay, but we can go on. But what are we then testing? We now have a zoo of other services. Is this still? Does this represent our real system? Well, I'd say no. It resembles. It maybe looks like it, but one thing that we also cannot actually test locally is the glue in between. So a lot of the ingredients, the resources I set up on AWS are not the instances that I have an IoT broker, but actually the connections, the rules, permissions, and all of this would then also not be tested. Because if I would wire up my replacements, this would be done A, in a totally different way, and B, I wouldn't have the same features, most likely. So it would be a lot of effort to build something that I can test locally. And in the rules and in the definitions of these relations, there's actually quite an amount, there's a big error surface. This is one example IoT rule which connects IoT with a Lambda. So a Lambda gets executed if a certain like message matches the condition. And I already in there have multiple like possibilities to make an error. I need to construct the event that the Lambda will be called with from the message. I need to select the right properties. I need to define the right topic it's selected from. So this is a source for error. If I make a typo in there, my solution will not work. So I need to actually test that. And I also need to make sure that the right Lambda is called. So I can make a mistake here and like in CDK land perfectly, or in CloudFormation land, put in any ARN. It will work. It just might not be a Lambda, or it might not be the right Lambda. So this can be an error as well. So that's a big problem. The AWS configuration, even if I find replacements for the services, the configuration part is then not testable because it will be different. And the important part is that is the actual important part of my solution. This is what like a lot of my time I spend on configuring the services. I don't want to care about the services. I just want that they behave in the right way and get the right events and produce another event, maybe store something. So, and this gets really, really extensive. For this project, we had at some point 3,500 lines of YAML to configure something, yeah, this is just not great. And so I have 3,500 lines of code which are not tested if I just run them locally. So that's just a huge piece of code that I need to test. So, and for me, the only way it's like led you to is actually testing it end to end. This is the only way I can ensure that it works and that I use all the real services, not my fake services or replacements. And now, how do I do this? That was then like my problem, finding a solution for that problem. And the solution is, as I said, is running it in production. I put a slide here because it's important to understand that in this project, we don't run the test in a production account. We run the tests in an account that has the same services and uses the same features as the production account. But in that setup, we were not able to basically do blue-green deployments or divert traffic to new services and run it in production. This is a prototype and a small project that started off with very limited user base. So we needed synthetic traffic anyway. And our solution is small enough that I can set up everything, including an Elasticsearch, which takes like 90% of the time, of the total time to set up, in 15 minutes. Which gives me an end-to-end test result after 40 minutes. And that is, for me, still okay. I will maybe talk a little bit later about how to test it. It's 40 minutes, yes, but as a developer, I can test this within 2 minutes. So the big difference as a developer, I have an account where the services are already there, and I test against that. So the feedback cycle for me as a developer, if I'm developing a feature, is still seconds or minutes. It's just for the entire quality gate that will take a longer time, but it's still under an hour. So the time is enough. And we didn't have the problem that we had a so huge setup that it wouldn't be possible to actually set it up within a reasonable amount of time. Nevertheless, what we need is infrastructure as a code. And I mentioned earlier that we use CloudFormation back then. And CloudFormation, who's not familiar with CloudFormation? Okay, a few. So yes, CloudFormation is a way to express the desired state of your AWS account, what services should be there, and what they should do. And you tell basically CloudFormation, hey, this is what I want, and CloudFormation figures out how to set it up. This is really amazing, but you need to write thousands and thousands of lines of YAML code, which is kind of really, it's really, really hard to, it's mind-numbing to review changes in YAML files. It's super boring and super error-prone if you have to repeat 50 times the definition for lambdas. Thank God, or whoever you pray to, Stulu, we have CDK. This was God sent at my point where okay, I need to figure out a way to write my own YAML generators. Then CDK came around, and I've been using it since the first public alpha, and it's really brilliant to use because it gives me a typed language and basically an SDK where I can, in my preferred editor, with code completion, describe my resources that I want, and I can easily define abstract constructs, like my default lambda, and then if I want to reuse a lambda with a different code set, it just becomes a two-liner, which makes it very easy to actually also do code reviews when we change stuff. If you change code in CloudFormation for changing the runtime, it can be 100, 150 lines, individual lines changes because somebody did search and replace. But you need to actually look at 150 lines that all of them were replaced correctly, and they didn't make a manual error. If you have a CDK code base, it's a one-line change because your base lambda the base class of that resource will change. So I really, really recommend that you take the time and look into CDK because it makes the development, especially when you start hitting the resource limit of 100 resources per stack, very, very easy to maintain multiple stacks. For NRF Cloud, I think we have 12 or 13 stacks. We have a lot of lambdas, a lot of rules, and that easily reaches the limit very quickly. So CDK, really great. There is actually a track at 1150 about CDK, so I haven't heard that talk, but I will be there. So it's always great to see how other people use CDK. So now we have something great to express our infrastructure as we want it, because that was the precondition, so we can run the tests. I want to set up everything for every test, everything that I need automatically, not manually. And I have that. And then I need production infrastructure. So I use all the services that I use, but some of the things in our solution are not under my control. So we have this receiver on the webhook receiver, which doesn't exist in my solution. This is not part of it. I just send an HTTP request. So I cannot basically trust that when my Lambda says, oh, cool, I created that request, that it actually arrives somewhere. So I could have made a configuration error. I could have put it in a VPC. I could have created a firewall rule. A lot of stuff could have happened. Why this request is not actually arriving, even if my Lambda thinks it sends it. It has sent it. So in that case, what we need is actually real test doubles. So we replace, or not actually we don't replace, we set up something that we can inspect in the test to see if our desired result, and that was the webhook, has actually been delivered. So for this part, which is outside of our solution, I set up a separate API gateway. This could even be in a separate zone, sorry, in a separate region. It could be in a separate account. The great part is that if you set it up really as an standalone stack or API gateway, you have all the guarantees that you want. The only thing that is that it's in the Amazon network, but it's a separate instance. It's not within your network, so you can be pretty sure that requests that you're sending to this API gateway from your Lambda, that this reflects roughly a real-world scenario. And what this API gateway does, it stores incoming webhooks in an SQS, which then the test runner can query and ask the queue, hey, what webhook requests did arrive? So I can, in my test, then verify that my solution sent the webhook that I wanted it to send. The source code for all of this, by the way, is open source, and it's available. So there's for the test runner itself, there's a small example which you can set up in your account, which shows you basically the mechanics with this webhook receiver example. I will share the slides on my Twitter, and they are on coderbyheart.com. And the project that I'm now working on is this end-to-end solution for an IoT cat tracker. Also uses this approach. So you have now, so I can give you two examples, real-world examples of how this looks like. So when you start testing this, one of the things that pop up is now suddenly your tests take more time, and you are now experiencing something that you don't when you run on your local machine. On your local machine, you probably have a very beefy machine, a lot of CPU, a lot of RAM. Your local database is actually a memory database, so everything is kind of like amazing. But that's not the real world. In the real world, stuff takes time. Lambdas have cold start time. Network requests from one instance to another take time. So that is actually that's a characteristic of your solution. So I find it interesting to have this problem in your tests, because this is what your users of your solution will also experience. And in our example, going back to that, we have a lot of areas for eventual consistency, which meaning that if a message arrives at the IoT broker, it will be sent to the Lambda within roughly maybe 400 milliseconds. It can take longer. It can, like all of these relations, can take a while that they are actually there and queryable. This is within your system. And then obviously you have stuff going out can also, again, take time. So an end-to-end test that tests from the incoming MQTT message to the result will always hit a lot of possible small timeouts or pauses between something becomes available. But this will sum up. There can be like maybe 5, 6 lambdas to get one thing done. And if you sum up all the cold starts, then you're easily at 10, 15 seconds. I know that AWS changed the cold start time, which is amazing. But so you're smiling. This is really great. And they changed it for lambdas in VPCs, which was even worse. Which is like this fantastic news. Nevertheless, we're talking still 150, 200 milliseconds for Node.js, and if you sum this up, it still takes more time than it would if you have running everything in your Node.js process locally. So one of the solutions, if you run an end-to-end test against that, is to use Backoff. So I run a test, and within that test, if I have an assertion and say, I wait that this message arrived, I probably will fail for the first try, but then I try again. So, and this is how a real user would also behave. If they create a message and then query a list of messages in your system, if the message isn't there, they will refresh, they will resend the request. So your test runner can do the same. There is an upper limit for how often I will do that and how long I will wait. So a classical Backoff just multiplies the wait time by 2. I personally kind of find the optimum is kind of 5 seconds. So there will be an immediate try, then I will try it after 1 second, after 2, after 4 seconds, and then every 5 seconds until I reach a total timeout of 30 seconds. And here's the interesting part now. You say 30 seconds, oh, that's kind of long. I say, well, for our solution and for our users, that's fine. And the interesting part now is that this becomes part of your discussion with your team. What kind of timeouts do we accept? What is okay for our solution? And you make them, through that process, you make them part of your development process. Because it becomes a conscious decision to say, okay, we won't wait 30 seconds. Tests must be completed, every test request or every scenario, within a second. And one tip there is important to do a warm-up run. So my tests, the end-to-end tests, they are actually running 2 times. In my code build spec, there is, in a pre-build, I actually run the tests, but I ignore the result. So it's the same command. The tests can be run multiple times, so there are no dependencies that need to be cleaned up to be able to run it again. So I run them, and this will probably fail for the first run, because then it will hit all the cold lambdas, and then the second run will actually count. So if that fails, if there are too many timeouts or the timeouts are too long, it will fail. But the second run will very likely hit all the hot lambdas, and you have, because we are testing in a blank account, we're not testing on production, so you will hit then, or you will then have your account in a state which is likely to represent if you have actually real traffic. And the lambdas are hot and stuff is smooth and buttery. So for all of these tests, I haven't showed you how I write them. I needed a new test runner. So I needed a way to express these tests in something that is manageable and that is also agnostic to what actually is the test driver. Because the drivers of the tests are a REST client, are an MQTT device, are a GraphQL client. So we have a bunch of different things that drive our tests. And I want one language and one framework, you could call it, where I can express these tests. If you think about writing all of them in a programming language, you can achieve that as well, but I find there is an added benefit if we look at writing BDD tests. Who is familiar with BDD? Some of you. Okay, so in BDD, I no longer iteratively express my test runner is clicking here and it's doing that. So the idea with BDD is that I write a very high-level scenario, it's called, which expresses what the system should be doing, and then it's the job of the implementation of that test runner to actually, under the hood, run the tests to fulfill the scenario. So in our case, looking back at the scenario that we have, the user story is so I want the outcome is a webhook call if an incoming message has a temperature above 5 degrees. So that is I don't need to go over that again, I think. And in our test files, this is actually the files that then we are using to drive the tests. It's a plain text English language, which has in every file the actual feature that we're testing. So you have the context of what should be happening. And then I decided to write the tests in the, thank you, write the tests in the language of the user. The user will be using a REST API because this is our contract to the user. We provide a REST API. We provide devices, a way to connect to IoT, and certain topics are available for them. So this is the level of abstraction that we provide, and we write tests on that level, on that abstraction. So I can in that concrete example, I use a language that's very similar to, or uses the HTTP verbs, so I can use a method like post and have a resource that I can post a JSON body to. My test runner will replace these placeholders, webhook receiver it's called here, replace them with the actual values from the test account. So in your test, you don't have to take care of that. And the same works for driving the MQTT device that sends in the message. So I provide for the test author a test device they can use, and then they can write what the device is doing. In that case, the device is sending a message with a T property that represents the temperature, which is way above 5 degrees. And in the last 2 lines, I have actually then the assertion. So I expect in the when scenario, I write what's happening, and then I write my assertion that the webhook receiver should be called, and we have this contract that the webhook receivers get called with a specific event. It's called notification state enabled. It doesn't matter what that really means, but this is a way I can verify that this webhook receiver that has been configured in the previous step here by the user, if the device sends in the message, gets actually called. When I run this test, this is the output of the test runner, and there we can see where the placeholders have been replaced. So the post to /alerts was automatically prefixed with the actual API gateway URL for the REST API that the user uses. And in the second test, then we see that what message was sent and what message was received on the webhook receiver as a debug output, kinda. And this test runner is also open source and is available as well on my GitHub account. In that example, I talked before about the webhook receiver example, and in that project, you will find exactly that sample. So it sets up a webhook receiver where you can send a JSON message to, and the test expects this message to arrive and shows you how you can mock, or not mock, kind of have external receivers and test if you depend on external services, and how that looks like in an actual output. So it runs on GitHub Actions now, so you can actually look at the test output. If it's not, oh, it's expired. Okay. So, okay, let's do this. That was expired. So, where's my mouse pointer? Yeah. Okay. So, to come to the end, where is my full screen? Sorry. Here. Okay. For me, the advantages of writing tests in that way is that it's very concise syntax. I have very little actual noise in my test. It's very explicit about what should happen, not really how it's happening. It doesn't doesn't set up the HTTP client and all the credentials and whatever. That is abstracted away. In these feature files, I can actually logically group a lot of the components I need. In a typical unit test, you would look at MQTT device being able to send stuff, then you have testing the REST API that it has methods, but you often don't really know how these components belong together. Writing them in a feature file, you provide a way for everybody to see, okay, for our users, we need these components, and these are tested in a way that how they belong together. They also don't change very often. This is running against the public API. So I can replace everything under the hood. I can replace API gateway with a Node.js Express server if I want to, without needing to change the test, because your public API most likely won't change. And that makes it really nice if you want to refactor stuff. I still can have these tests. I don't need to change them, and they're there during my refactoring and provide real safety that my refactoring still works. And for your product managers, your managers yourself, your team has always an up-to-date view of what's actually working in the system. It's a directory of text files that describe everything what's in this folder is actually working, which is a great way of showing and being very precise about the capabilities of your system, when they were implemented, and how they relate together. So, one important note is that I still have a lot of unit tests. So, end-to-end tests always test the happy path. They are not good at actually being expressive. If you discover a bug in an end-to-end test, it will be very, very hard to figure out where the source is. A unit test is much more close to the source and gives you better information if something is broken. So always have this combination. But I typically limit my unit tests now to critical implementation, stuff that maybe persists data. But these end-to-end tests for me provide a very huge value and safety so that I can focus the unit tests on only the critical parts and don't have 100% code coverage. So that brings me to the end. To sum up, we learned run your tests in production, in parentheses on production hardware or on production services. Express your infrastructure in code. That's important. Everybody should do that. One of the few shoulds that we should accept. Run tests like a real user would do. Unit tests give a false impression of speed and reliability. Run your tests with a backoff so that you deal with these timeouts. And write a test in a high-level language because that gives you a better understanding of what your system does. Last slide, I recommend these two books. If you want to think more in how to design systems like this, REST in Practice is, I kind of think, a very underappreciated book. I love it very much. And most of you, I guess, have heard about Accelerate, but this is one of the books that everybody needs to read right now. Questions? I'm here now for the rest of the day. Please give me feedback on that talk. It's super important as a speaker to get that. My DMs are open. I'm on Twitter. If you have questions now, later, you can always reach me on Twitter. Thank you for listening.